Hi, welcome to Chem with Chem. In this session, we will be working question 1 of chemistry paper 2 from the June 2019 sitting. If this is your first time to the channel, welcome. Be sure to check out all the other materials that are here. And if you find value, please give it a thumbs up, share with your friends, and consider subscribing and turning on post notifications so you will not miss when new content is added. Let's begin. Now, question 1 is a data analysis question, as is customary, and we're being recommended not to spend more than 30 minutes on this question. Now, this one is a mouthful, so let's just zone in and get everything clear. Let's just get in and just see how best we can understand, interpret, and just get full marks. Michael and Jennifer were assigned a group project to investigate the effect of surface area on the rate of reaction between zinc metal and the dilute sulfuric acid. And this is becoming, I don't want to say, we're seeing a pattern, but we tend to get these types of questions for number 1. You know, it's a lot of titration or rates of reaction, but they tend to mirror experiments that would carry out in the lab. So they obtained 6 different grades of granulated zinc. The grades represent the average size of the radius in microns, micrometer, of the granules. 6 experiments were carried out using the different grades of zinc granules, which were reacted with an excess of 0.5 moles per dm cube dilute sulfuric acid at 25 degrees Celsius. Very important. So temperature is held constant and excess acid is used to ensure that all the zinc granules is used up. The same mass, very important, the same mass, 0.55 grams of zinc granules was used in all experiments, and the time taken to collect 100 centimeters cube of hydrogen gas was noted as shown in table 1 on page 6. So we're not going to directly go to table 1 on page 6, all right? Just for ease of scrolling, we're going to just go straight into recording the readings that are shown on the stopwatch. So in question 1, a data analysis question, we're always given some instruments with gradation that we'll have to find out the scale, and we'll have to do some reading. So we're just going to make a note of that. So when we go to page 6, we can just fill in the values and just do whatever calculations are required there regarding the rate. All right. So we're going to make a note of the time taken in each experiment. All right. So firstly, we always figure out the scale on whatever instrument we're using. So in this case, each of these little strokes that we see, they're representing 1 second, right? So it's a 1 minute stopwatch. Each of them is representing a second. So it means therefore that what we have here for experiment 1 is 11 seconds, 11.0 seconds, right? Experiment 2, that would be 20 seconds, 20.0 seconds. Experiment 3, that would be 30, 31, 32.0 seconds. Experiment 4 would be 43.5 seconds. If you have 43, you should still get the mark. Experiment 5, 52.0 seconds, and experiment 6, 58.5 seconds. So we're going to take those and we're going to put them in our table, which comes next. But just for ease of scrolling, we're doing our readings right now. So table 1, this is the data obtained for experiments 1 to 6. Part 1, from the stopwatches displayed in figure 1 on page 5, record the times for the hydrogen gas to be collected in column 3 in table 1. The time taken for experiment 1 has already been recorded for you. So we're just going to fill in our table. So we have 20.0, 32.0, 43.5 for experiment 4, experiment 5, 52.0, experiment 6, 58.5. And we're not doing this in a vacuum. I would like us to look at the diameter, sorry, the radius of the zinc grade that we're using. So we realize that so in experiment 1, we had zinc granules with 0.8 microns, and they kept on increasing. Experiment 2, 1.9, experiment 3, 3.0. So the radius was getting larger and larger. So this is telling us that, well, we know, well, I shouldn't say we know. The larger the radius, then it's telling us that the surface area is smaller. So the smaller the radius, the larger the surface area. Just need to bear that in mind. Smaller particles have larger surface area. So let's look at the time now. So for the one with the smallest radius of 0.8, we notice that it took 11 seconds for 100 cm cube of gas to be formed. Let's compare that with the one with the largest radius, which would have the smallest surface area. 6.3 microns, that one took all of 58.5 seconds. So it took longer. So the larger the radius, the smaller the surface area. In a sense, we're saying the smaller the surface area, the slower the rate of reaction, or the smaller the surface area, the more time it takes for the 100 centimeters cube of gas to be formed. So that was part 1, and we got 3 marks just now. Part 2, using the formula rate is equal to 1 over time, calculate the rate of reaction for each experiment and record these values to 3 decimal places in column 4 of table 1. The rate of reaction for experiment 1 has already been calculated for you. So we're just going to say 1 divided by whatever the time is. So in experiment 2, it's 1 divided by 20, which will give us 0.050. I said 3 decimal places. And then 1 divided by 32, that would be 0.031. Then there is 1 divided by 43.5, 0.024. Then 1 divided by 52, 0.019. And then there's 1 divided by 58.5, which will give us 0.017. And 3 more marks. So in the next question, we're going to be plotting a graph of the rates. So all that we have in column 4, rates of reaction versus the time. So rates will be on the y-axis and time will be on the x-axis. So that's what we're going to be doing next. So make a note of these values, have them ready so we can plot in the next question. So in part 3, using the grid provided on page 7, plot a graph of rate versus time for experiments 1 to 6. Draw the best curve through the points. What's very important when we're going to plot, or before we even plot, is that we determine the scale that is being used on the x and the y-axis. So on the y-axis, we're seeing that 2 centimeters are being used. So the scale, we're seeing that 2 cm, 2 centimeters are being used to represent 0.01 units, right? So it means that each of the little millimeter boxes that we have there, each of them is representing 0.001. All right, so each of them will be going up by 0.001. All right, on the x-axis, we have the scale on the x-axis, we'll have 2 centimeters representing 10 units. It's been used to represent 10 seconds. So it means each of the little boxes, each of the little boxes there, the millimeter box is going to be used to represent 1 second. So it's a little easier. And in the interest of time, I've gone ahead and I've plotted the points. So for 11, we'd find 11 seconds on the x-axis and would come up and we'd look for the rate that corresponds with 11 seconds. So that would be 0.091, and that's plotted. We do the same thing, 20.05, 20 seconds, 0.05, then 32.031, and so on. The next thing we would need to do is to draw the best fit, the best curve. And the best curve will go through most of the points. Sometimes we'll go through all of them. Other times it will not go through all of them. So we want to do the best curve, and it should be smooth. We want to do it in one go. So here we go. So that's what your best curve would look like. Mine is a little wiggly in some areas, not as smooth based on the device that I'm using. So that would give us the full marks there. We can just look to see what is happening here. We're seeing that as time increases, as you go across on the x-axis, you see where the rate is decreasing. And more than likely, we should expect a question like this, because there's normally a question asking us to interpret the graph to see what the trend is. So as you go across on the x-axis, you're seeing that the rate is decreasing. The rate is decreasing. All right. And we can put that into better perspective. If we were to go back to the table we had with the zinc grade, we're finding that the smaller the radius of the zinc grade, the faster the rate, or the shorter the time it took for the 100 centimeters cube of gas, to be formed, or just the smaller the radius, the faster the rate. And the smaller the radius, the larger the surface area. That's the link that I think I had mentioned earlier. B, part 1, based on the graph plotted on page 7, deduce how the rate of the reaction varied with time. So we'll say it simply, as time progresses, as time progresses, the rate of the reaction slows down, or we could say the rate of reaction decreases as time progresses. I don't fancy this question at all. Anyway, moving right along. Part 2, explain how the trend in the rate of reaction stated in B1 relates to the surface area of the zinc granules. So this trend that we saw in B1, we looked at the graph earlier, it's directly related to the surface area. So we have to make it clear though that the smaller the radius, the larger the surface area. We probably don't have to state it here, but we can just get straight to the point. So for 2 marks, the larger the surface area, the faster the rate of reaction. The larger the surface area, the less time it took for the reaction to be completed. So all right, so the larger the surface area of the zinc granules, the faster the rate of reaction. 2 marks. Part 3 of B. List 3 factors other than surface area that affect the rate of a reaction, the rate of a reaction in general. So besides surface area, we have concentration, we have temperature, and we have the use of a catalyst. They did not say this reaction in general, they said rate of a reaction. State 1 safety precaution that Michael and Jennifer may have taken during the experiment, and it's always safe to say wear enough protective gears. PPE, right? So gloves and goggles, lab coat. D, state one way in which Michael and Jennifer may have controlled the temperature during the experiment. So they said this was held at 25 degrees Celsius, taken to the room temperature. They could have used a styrofoam cup, you know, an insulated system where heat would not enter or leave. So they could have used, or they may have, or they could have insulated the container in which the reaction took place. So this part is the last section, E. It has 2 parts for 5 marks. Part 1, 2 marks. Part 2, 3 marks to make it up to 25. Write a balanced chemical equation including state symbols for the reaction between zinc metal and sulfuric acid. So this is Zn, which is a solid, plus H2SO4 aqueous to give zinc sulfate, ZnSO4 aqueous plus H2 gas. So just writing this as is, it's balanced, 2 marks. Part 2, calculate the total volume of hydrogen gas that would be produced at RTP from 0.55 grams of zinc granules. Okay, so this calculation is going to be governed by our balanced chemical equation. So from this balanced chemical equation, we're seeing where 1 mole of zinc, let's change color, 1 mole of zinc reacts to give us 1 mole of hydrogen gas. And we're just focusing on the hydrogen gas because the question is asking us about hydrogen gas and zinc. So let's move from moles now. 1 mole of zinc, well, the RAM of zinc is 65.4. So 1 mole of zinc has a mass of 65.4 grams. So we're saying 65.4 grams of zinc produce 24,000 cm cube of hydrogen gas at RTP. So that is going to be our first statement. And we can just take that down. So we'll say from the equation, we're saying that 65.4 grams of Zn react to give us 24,000 cm cube of H2 gas at RTP. So we want to find out if we actually used 0.55 grams of zinc under the same conditions, what volume of gas would we end up with? So we put X right there, and it follows that we would end up with less because 0.5 is less than 65.4. So we'll just cross multiply. So we normally put on lines there to say we're going across the diagonals. So it would mean then that 65.4 grams times X is equal to 0.55 grams times 24,000 cm cube. We want to make X the subject, so we divide by 65.4 grams on both sides. All right, and of course, we know 65.4 grams cancel out 65.4 grams. So it's a matter of punching in into our calculator now, and we write down our value. So we would end up with 0.55 times 24,000. Whatever we get divided by 65.4, and that would give us 201.8 cm cube. And that is our answer. That would give us the remaining 3 marks to make it up to 25 marks. And just like that, 25 marks. If you found value in this video, in this session, then just hit the thumbs up button. Please share with your friends. If you haven't subscribed, consider subscribing and turning on post notification. That's clicking the bell, so you'll be notified each time new content is added. This has been Chem with Chem. Couple later.